Welcome back to my channel. In this lecture we'll be looking at vectors. Vectors is very important. So yes, if you haven't subscribed, if you are new to this channel, or you are not new but you have been watching my content, you've been following me, please subscribe and turn on the notification bell. Very important. This is how you can support this channel. Okay, so yes, we are talking about vectors. So what are vectors? So vectors are quantities that has both magnitude and direction. So vectors are quantities that has both magnitude and direction. So if, for example, we have this line, so this is O, this is P, so the vector will just be OP. Okay, so it is this is more like the position vector. So we have like a high plus bj plus ck. So why are we having high j and k? We're having high j and k because they are the coordinates. We are studying vectors on R3. Okay, so this vector is on R3. Okay, so this is your x, z and y. So this is where the I is, this is where the j is, this is where the z is, so the k. So the I is representing the x-axis, the j is representing the y side, and the z is representing, the k is representing the y side. Okay, so that is why we have all this. Is used to show their direction. Okay, so these are vectors. And it's important, we denote it using that arrow. So this is a vector. So when they ask you to calculate the magnitude, so how do you get the magnitude of this vector? So the magnitude of OP is given as a squared plus b squared plus c squared, and then we find the square root. So this is what we call the magnitude. This is how to get the magnitude. Okay, so let's talk about vector addition. So let's do vector addition. Okay, all right, so if I have let's do an example. Okay, so giving a to be equal to let's say 2 1 5, b is equal to 1 3 6, and c is equals to 5 0 1. So find 1. We have 2a plus 3b. 2, you have c minus 2b. Question 3, you have the magnitude of 2a plus 3b. So that will be all. I think I should change this to question 3, change this to question 2. So let's use this example to practice how to go about addition of vectors. Okay, so yes, for the first one we have 2a plus 3b. Okay, so what is a? A is 2 1 5, b is 1 3 6. So vectors can be represented in this form, and you can also, this is a row form, you can also write it in column form. 2 1 5 and 3 equals 1 3 plus 3 equals 1 3 6. So this is how I love to add my vectors. It is easy this way. So 2 times that will give you 4, 2 times 1 will give you 2, 2 times that will give you 10. So plus 3 times 1 is 3, 3 times 3 is 9, 3 times that is 12. is 18. Okay, so if you add up the terms, you get 12, you get 7, you get 2 plus 9, you get what, 11, and the last one will give you 28. So that is the answer for that. So the 2a plus 3b is, this is 2a plus 3b. Okay, so this can also be written as 7i plus 11j plus 28k. This one can also be written as 7, 11, 28, like this. Okay, so these are the way you can write your answer. So I think the question 2 now is to find the magnitude of this answer. So the magnitude of this will give you 7 squared plus 11 squared plus 28 squared. Okay, so that will give you 49 plus 121 plus 28 squared. (28 squared will give us 784. So this will give you, so if you sum that up, plus 121, so that is the magnitude. So let's do the last one. So the last one involves c. So the question says c minus 2b. So please always put the arrow to denote vectors. So what is this c? 501 minus 2 times 13136. So this will give you 501, 2 times that 2 times 3 6, 3 times 3, 2 times that is 12. Okay, so how do you minus? Let's use this method then. How do you subtract? The same coordinates will minus themselves, so you can do 5 minus 2. So 5 minus 2 is 3, 0 minus 6 is minus 6, 1 minus 12 is minus 11. So this is the answer for that. Okay, so take note of that. I want us to also know that this c, which is 501, if I'm to write it in another form, that would be 5i plus k. So whenever you see 5i plus k, it means that the j part, you have to put 0 there. So just add that to what you learned from this section. Alright, so the next thing to learn is unit vector. Unit vector. So how do we find unit vector? So given u to be, this is a vector now, to be vector, let's say a1 plus b, ai plus bj plus ck. So what is the unit vector? So the unit vector is denoted with u cap. It is the vector u divided by the magnitude of u. Okay, so you have bj plus ck divided by the magnitude, so which is u. So what is the magnitude? You have a squared plus b squared plus c squared, and then you get square roots. So note that the magnitude of u of the unit vector is always 1. Okay, so if we are to do an example, so giving u to be equals to 2i plus 3j plus 4k. Okay, so find the unit vector. So solution, we have we need u is 2i plus 3j plus 4k. So where is the magnitude? You have 2 squared plus 3 squared plus 4 squared. Okay, so that would be 4 plus 9 plus 16. Okay, so that is 25 plus 4, that will give you 29. So the unit vector will be this vector divided by the magnitude. That is 2i plus 3j plus 4k. Divide everything by 29. So you split it, you get this plus 3j over root 29 plus 4k over root 29. So this is how you write your final answer, vector. Alright, so let's move on to scalar let's move on to multiplication of vector, or let's say vector products. So vector products, it is very important you know how the vector product works. We have two types. So the first one is the dot or the scalar product, and the second one is the cross product, although they also call it the vector product though. So let's just leave it as cross product. So let's discuss them one by one. So firstly, let's talk about the scalar product in this video. So let's say we have two vectors. We have vector A to be A high plus A1 high plus A2j plus A3k, and then you have B to be B1 high, B2j plus B3k. Okay, so what is the dot product of the two vectors? So that is what we call the scalar product. So it is equal to the magnitude of A times cos of angle of the two. The A and B, they are like this. So this is vector A, this is vector B. Okay, so there's an angle in between them, so that is it. Okay, so this is the formula for dot product. So but before we proceed, let's talk about how to do this left hand side. This dot product is equivalent to this, so it means that if they say you find the dot product and you know the magnitude of A, the magnitude of B, and you also know the angle between them, you can use this to evaluate the dot product. But if you have the vector, like A is given like as this, B is given as this, they say you should find the dot product, you don't need to use this other side, just do the dot product. This is how dot product works. So this for the A part, you can write as this A1, A2, and then A3. For the B part, it is B1, B2, B3. So what you will do to be A1 times B1 plus A2 times B2 plus A3 times B3. Okay, so then you sum them up. So this is how to do the dot product. Okay, so an example, I'll still come back to the formula again, so but let's do an example. I could say, so solution. So A is given to be that. So the A dot B now, let's just go straight to the point. It will be 2, 3 minus 4 dot 1, 5, 0. So that is 3 times 1, 2 times 1 plus 3 times 5 minus 4 times 0. 2 times 1 is 2, 3 times that is 15 minus 0, so you just get 17. So A dot B is equals to 17. So this is the dot product. Alright, so now you've seen an example to illustrate how dot product works, but then let's go back to the formula, because there are some questions you could be asked using that formula. So we have A dot B is equal to the magnitude of A times the magnitude of B, then cos theta. So sometimes you could be asked to calculate the acute angle, or the acute angle between A and B. So if they ask you to calculate the angle between A and B, so you can use this formula, and what can you do? If you divide by this, you will get cos theta is equals to A dot B divided by their magnitude. Okay, so what is theta? So theta is equals to shift cos A dot B divided by the magnitude, the product of their magnitude. So this will give you the angle between them. So example, so giving A to B, we can use the previous A we've used before, which is 2i minus 3j, 2i plus 3j minus 4k, then B is equals to I plus 5j. So find the angle between A and B. Solution. So how do you find the angle? So remember, theta is equals to shift cos into A dot B over the magnitude. Okay, so how do you find the magnitude? So A dot B, we've done it before in the previous example. A dot B, we get 17. So I'm just going to use the 17. So the magnitude of A now will be 2 squared plus 3 squared plus minus 4 squared, and then you put square root. So this will be 4 plus 9 plus 16, and that will give you 20. Is it 29? So you get 29. 25 plus 4, 29. Okay, then for B, we get 1 squared plus 5 squared, so that is 26. Okay, so what is the angle between them? So we say shift cos into A dot B is 17 divided by root 29 times root 26. So let's use our calculator to compute that. What do we get? So you get 17 divided by the square root of 29 times the square root of 26. What have I done? Okay, if you do the square root of 29 times 26. Okay, so if you do the denominator, you should get, if you multiply those two, you get 27.46. Okay, now 17 divided by 27.46, so that will give you 0.6191. okay, so shift cos 0.6191, so that will give you 51.5 0.75. So that is the angle between A and B. Do we understand that? Alright, so that is for the angle between them. Now there is another thing I want us to know. We are talking about A dots. We are still on scalar product, so we will be doing everything that involves the scalar product in this video. Okay, so all the kind of questions you could be asked in any exam on scalar product, so that is what we are just dealing with. So with this, you could be asked. Okay, now let's look at this. If A and B are what? Are parallel, or let's say perpendicular. This is where I'm going to. What do you think the angle between them will be if they are perpendicular like this? You have A to be this, and then this other one is B. They are perpendicular to themselves. What will the angle be? The angle will be 90 degrees. So if the angle is 90 degrees, cos 90 will give you 0. What that means is that A dot B is equal to 0. That is the implication of that. Okay, so A dot B is equal to 0. But if the A and B are parallel, the angle will be 0. There won't be angle between them, and cos 0 will be 1. So it means that the A dot B will be equals to their product of their magnitude. Okay, so this is because I know you will be like, what happens when they are parallel? So this is the formula for this, how it will look like when they are parallel. But there are still other beautiful conditions for parallel. But you see this perpendicular, very, very important. There are a lot of questions you could be asked saying, if two vectors are perpendicular, show that two vectors are perpendicular. If given that they are perpendicular, find this. So I think we'll do one example on that. Let's do example on perpendicular. Let me write the question out. Question. Okay, so it says determine the value of Q such that the vector A equals 2qi minus qj minus 4k and B equals qi minus 2j plus k are what? Are perpendicular. That is the question. So you could see there is Q, there is a point missing in A, there is another one missing in B. So the question say that we should find Q if the two vectors are what? Perpendicular. So that is where you now use your dot product. You just have to remember that if two vectors are perpendicular, their dot product is 0. Okay, so let's find their dot product. So we get 2q minus q, then minus 4 dot B is q minus 2 then 1 is equal to 0. So let's take their dot product. So we get 2q squared, wow, then plus 2q then minus 4 equals to 0. Something is common, which is 2. If I bring out 2, I get q squared plus q minus 2 equals 0. Okay, so from here it is this one in bracket that I will just equate to 0. Okay, so two numbers that I would times that will give me -2. If I add them to give me 1, so that is 1, that is 1 and -2. 1 times -2, no, plus 2 and -1. Yes, so my quadratic equation will just be -1 then q plus 2 equals 0. So q is equals to 1 and q is equals to -2. So this is the possible values for q. Okay, so these are the possible value for q if they are perpendicular. So another thing that involves the dot product is work done. So let me just ship this in. We can be asked to calculate the work done. So work done is force times the distance covered by the object, and the unit for work done is joules. So the unit for work done is joules. So but the D could be displacement though. The D could be displacement. I've not talked about displacement in this video. Okay, we'll see that now. So this is the formula for displacement. If I have vector a b, so what is the displacement? So the displacement vector will be vector b minus vector a. That is what we call displacement. So, and why is it like that? It's because if I have vector a and I have vector b, so to calculate the distance between their two, it has to be b minus a. Do you get? So that is what we call the displacement vector. Okay, so that is the displacement vector. So let's do the work done. Coming back to this, work done formula is equals to the force times the distance. Okay, so let's look for an example. Okay, so let's discuss it. So the work done, like we said before, is force times the distance, but you could see a is displaced to b. We need the displacement vector, so that would be b minus a. Okay, so b minus a is what? So we get 1 minus 2 minus 3 minus 5, 0 minus 3. So that would be -1 minus 8 then 3 plus 3. 1 minus 2 minus 3 minus 5. So that is b. That is AB. So work done is, so this is our D. We can call it D2 in that formula. If your D is anything. So so we get 2 minus 5, 4. Where did I get 2 from? That is your force. Your force is 2 minus 5, 4. Okay, so dot -1 minus 8 then 3. That will give you -2 plus 40 then plus 12. That will give you 50 joules. So that is the work done. Okay, so this is your work done. Alright, so this will be the end of this video. See you in the next one.